And welcome back to another video. This is me just documenting my practice of LeetCode problems for interview preparation. And today I'm looking at greedy problems. So what we have here is one of the problems from the LeetCode 150 list, maximum subarray. And yeah, I'm just going to try to solve this one. So let's first read the description as we would in an interview. So given an integer array nums, find the subarray with the largest sum and return its sum. And next step is to figure out what the constraints are. On LeetCode, they're given in text. And we can see that we have one element in our numbers array, and we have negative and positive values. Right. Okay, so next would be to go through a couple of examples to understand exactly, how we might compute a solution. This is, by the way, a very useful technique. If you don't see a solution right away, work through some examples and see if you identify a pattern that you can translate into code. You'd be surprised how often you come up with a systematic approach, even if it's not the most optimal one, but you'll be at least able to figure out how to solve the problem. Right, so let's start here. So subarray sum. I guess we could build something like a prefix sum maybe. Or we could use like a sliding window. That's what I'm currently thinking. So if we have here, the maximum subarray is from 4 to 1, which is this. And if we were to start with a sliding window, I guess, yeah, as soon as the values are negative. So I'm seeing right now that if I have -2, I collect that, and the next number is positive, the result is still -1. But if I just forget everything before, I would have a sum of 1. Now I run into the -3, so I'm at -2. And now I run into the 4, so that's +2. But again, I was in a negative before, so I could just forget the negative and just continue with 4 as my maximum sum. Right, so 4 minus 1 is +3. I'll probably keep that for now. Then I run into the 4, so that's plus 5, plus 6. Then I go to -5. And then I go back to, I go back to +1 by subtracting 5 from 6. And then I add 4, which is 5. Right. Okay. Let's see if that technique works with the other examples. We just have one number. Well, that's going to be our maximum. Maybe we have to, maybe that's an edge case where we say if we only have one number, then maximum sum is just that number. Let's look at the third example. So here we'd start with 5 plus 4 is 9, minus 1 is still 8, plus 7, that's 15, plus 8, that's 23. Okay. So that worked as well. Now I'm just curious, this technique where we say, okay, if we have a positive number and then we run into a negative number and another negative number and say then a positive number, does that change anything? So we are at 1, -1, and if we forget this, we'll be as -3. Flip this around. We would have 1 minus 3 is -2. But if it's negative, let's forget this. And then we have a sum of -1. And we will try to forget this as well. As soon as, yeah, I think that would work actually. So I'm going to try to implement this. And this would be an of-n solution. And we don't need to store anything except for the current sum. So it would be of-n time and o(1). We have a result variable. Now the maximum sum, we don't know what it's going to be. So maybe you just assume the first value in the nums array, that's a valid sum. We don't know if it's the maximum yet, but if we pick that, then we certainly can make a mistake, right? And then we just iterate over the numbers in the array for n in nums, and we will update our result and whatever the current sum is, I guess. We also have to initialize the current sum 0. And yeah, so, and we would have to say current sum plus equals n. So if we do that, then we compute the total sum of the array. But if our current sum is smaller than 0, well, that's the same as resetting it, right? So we could just say the current sum is 0. Yeah, I think that's it. So that is definitely the implementation that I just saw while going here through this. I'm not 100% sure if this will work, but I think it should work. So I'm going to test this now. Right, so it worked as expected. And I'm going to sub. Right. Cool. So that passes. And yeah, and I guess the approach is greedy because we're trying to build up the maximum sum. As soon as the sum goes below 0, we're just going to throw it away, pretend that we're starting from scratch. Because yeah, and we're going to start from scratch because if the sum is already negative, if the next value is also negative, it'll just make the sum even lower. So that's a good reason to throw away the current sum and start new. And the other case is if the current sum is negative and the next value is positive, that's another reason to throw away the current sum and start fresh with a positive value. So yeah, so that